Hi there. In today's video, we're going to go through skill 58, which is in our pink packet found by the door. This skill is pretty long, so hang in there. But your reward at the end is no mastery check. So we'll start with question 27. Which scenario is best described as an observational study? So when we collect data in statistics, there's a bunch of ways to collect the data. And when you're doing an observational study, that means you're watching something happen and you're not interfering in any way. Or you're going back to something that's already happening and you're just looking at the data that was collected naturally. So choice B is the answer to this one. A social researcher wants to learn whether or not there's a link between attendance and grades. She gathers data from 15 school districts. This data already existed. She didn't force anything different to happen. She just went and got the data. That's an observational study. All right, number 28, a candidate for a political office commissioned a poll. The staff received responses from 900 likely voters, and 55% of them they would vote for the candidate. The staff then conducted a simulation for 1,000 more polls than 900 voters, assuming that 55% of voters would vote for their candidate. The output of the simulation is shown in the diagram below. So they asked a group of people, would you vote for our candidate? And 55% said yes out of the 900 people. And then they simulated this 1,000 more times because we know that the one survey they did do doesn't necessarily represent what's actually going to happen. But if we simulate it 1,000 more times, we'll get a better idea of what might happen. So this graph here shows how often each percentage answer happened. So in this case right here, 50% of the people surveyed in this fake simulation result said they would vote for this candidate. This bar is a little taller, so maybe that's like 2 times they did this simulation. 50% of people said they'd do this, right? So this graph, you can see it's a bell-shaped curve. This is normally distributed. And when that happens, when they ask for a 95% confidence error, and they're asking for the margin of error, what you're going to do is you're going to take the average, and you're going to add and subtract the standard deviation twice. Now, in this question, they don't give you the standard deviation, but what we can do is look at all these choices and double them all, and see which window would have 95% of the bars shown here. So if we do 55% plus or minus 0.01 or 0.03 or 0.06 or 0.012, if we do the average plus or minus the standard deviation, which are the 4 choices here, will we get the correct margin of error here? So when I did this one, 55 plus or minus 0.03, we get 0.52 to 0.58. So does that contain 95% of the data? It does. So the answer to this one is B. Number 29. In 2013, approximately 1.6 million students took the critical reading portion of the SAT. The mean score, modal score, standard deviation were calculated to be 496, 430, and 115. Which interval reflects 95% of the scores? So to find the 95%, we want to do the mean plus or minus 2 standard deviations. So they told us the mean is 496, so I know it's choice C or D. Then plus or minus 2 standard deviations. Standard deviation is 115. 2 standard deviations would be 230. So 496 plus or minus 230. This is a standard fact that when you have 95% of the data in a normally distributed set of data, normally distributed means it makes a ball shape. And when you have 95% of the data, you can figure out the window that contains 95% by doing the mean plus or minus 2 standard deviations. Remember, standard deviation is the average distance each value is from the average. Number 30, according to a study, 45% of Americans have type O blood. If a random number generator produces 3-digit values from 000 to 999, which values would represent those having type O blood? So when we do stats, sometimes we collect data and sometimes we want to do simulations. We want to pretend to collect data. So that's what we're doing here. We're going to pretend to collect data by using a calculator or a computer, and it's going to randomly generate 3-digit numbers. If it's generating the numbers 000 through 999, that's 1,000 different values. I know it might seem like 999 values, but value 000 is the first number, and value 001 is the second number. So all of these are one off, right? The first number is not 001, the first number is 000. So that means the 1,000th number is 999. And if they want us to simulate having type O blood, we need to have 45% of 1,000, which is 450. So we need the first 450 numbers, which in this case is 449. And inclusive means make sure we include those numbers 000 and 449. So the answer to number 30 is choice C. Number 31, a grocery store owner wonders how many customers bring reusable bags to the store. They stand at the entrance for 2 hours and count the number of people bringing in the bags. Just like the last page, this is an observational study. They're not influencing the study at all. They're just watching what's happening, right? They didn't control anything about this. They just watch what's going on. That means it's an observational study. C. Number 32, Gabriel performed an experiment to see if planting 13 tomato plants in black plastic mulch leads to larger tomatoes than if 13 plants were planted without mulch. He observed that the average weight of the tomatoes from tomato plants grown in black plastic mulch was 5 ounces greater than from those plants planted without mulch. To determine if the observed difference is statistically significant, he re-randomized the tomato groups 100 times but studied these random differences in the mean weights. The output of a simulation is summarized in the dot plot below. So basically, they put the plants in 2 random groups and then analyzed the results, and they did that 100 different times with the same plants, just putting them in different groups. And they want to know, does the groups that they're in make a difference? The answer to this one is choice B. There was an effect observed that could be due to the random assignment of the plants of the groups. Why is there such a variation between the plants in each group? And that must be because the random groupings made a difference, right? So remember, when you do stats, you always want to find a way to make every part of it random or unbiased or controlled. And picking random groups to put each plant on clearly is having an impact, because look at how much different the data is changing based on the groups. Each dot represents how far off the average weight in the group is from the average. 33. Suppose 2 sets of test scores have the same mean but different standard deviations. Standard deviation 1 and standard deviation 2. And we know that standard deviation 2 is greater than standard deviation 1. When you have an average, that describes the middle value, right? The central tendency of the data. But the standard deviation tells you how varied the data is. And the larger the standard deviation, the more spread out the data is. So if the averages are the same, but this standard deviation is much bigger than this standard deviation, then that means that data set 2 has greater variability. By the way, this symbol is lowercase sigma, and that represents standard deviation. I explained down here, high standard deviation should have high variability. Number 34, in a small city, there are 22 gas stations. The mean price for a gallon of regular gas was $2.12 with a standard deviation of 0.055 cents. The distribution of the data was approximately normal. Given this information, the middle 95% is, remember to find the middle 95% if the data is normal, is to take the average and add double the standard deviation, and then take the average and subtract double the standard deviation, which is what I did here. I did the average plus or minus double the standard deviation. We end up with 212 plus or minus 10 cents, or 202 through 222. Those are the low and high number from this problem. Number 35, a sociologist reviews randomly selected surveillance videos from a public park. I can stop right there. Randomly selected videos from a public park. They're just watching what people are doing. That's an observational study. They didn't control any part of it. This has already happened in history. They're just watching it. Number 36, the company wishes to determine the cooking time for a pound of spaghetti. They cook a pound and recorded the time needed. Repeating this process 35 times represented a normal distribution with a mean of 9.82 minutes and a standard deviation of 1.4 minutes. Which interval is the middle 95%? So I'm being very redundant here. The middle 95% is the average plus or minus double the standard deviation. So the average plus or minus double the standard deviation. So when I have these two numbers, I get 12.62. And when I subtract these two numbers, I get 7.02. That's why choice B is the answer. Now we're actually going to do a question that's not an observational study. Number 37, a veterinary pharmaceutical company plans to test a new drug to treat a common intestinal infection among puppies. Puppies are randomly assigned to two equal groups. Half of the puppies get the drug. The other half gets a placebo. This is a controlled experiment because they're controlling the outcome. When they take half of the people or half of the puppies in the study and give them the real medicine, and the other half and give them a fake, a placebo, that means you're controlling the outcomes because you want to compare the results. That's a controlled experiment. A census is when you ask everyone their thoughts. An observational study is when you just watch something and not interfere. And a survey is when you ask everyone for their results. So it's not any of those. It's a controlled experiment. Number 38, Marissa and Sydney are trying to determine if there's enough interest in their school to put on a senior musical. They randomly surveyed 100 members of the survey senior class, and 43% of them said they would be interested. They conducted a simulate of 500 more surveys, and this is the curve showing all the studies from the simulation. The standard deviation of this study is closest to, so remember, we want 95% of the dots here to be within 2 standard deviations of the average. So if this is the average,
you'll equal the you'll get it.
And plus or minus the standard deviation,
You'll get it.
these are all the possible standard deviations. So if I double this, double this, double this, and double this, and add and subtract it to the average, which one makes the 95% window? It's this one, right? 43% plus or minus double 5% would make a window between 0.33 and 0.533, or 0.53. That's 95% of the docs roughly, right? There's a little outliers, but that's roughly 95% of the data. And number 39, we have another controlled experiment B. They have bean plants, and they put one group by the window and one group under artificial light. As soon as I see they're controlling what's happening in the study, and they're comparing the two studies, that's a controlled experiment. Choice B. All right, number 40, which statement about statistical studies is true? So we just have to read all 4 of these statements and see which one's true. This one's true. Survey of all English classes in a high school is a good sample to determine the number of hours students throughout the school year studying. Every kid takes English, right? And to talk to all English kids would pretty much get all the kids in the school. Number 2 is only talking to 9th graders in the high school to determine if there's enough parking spaces. The 9th graders don't drive, so don't talk to 9th graders. You want that study to be done. Number 3, a survey of all students in one lunch period would be a good sample to determine the number of hours adults spend on social media. Why would we go to a cafeteria in a high school to talk about adults? So not that one. And then number 4, let's talk to calculus students and see how much they like math. Well, if they're in calculus, they probably like math, so it's biased, right? So the only one that's unbiased here is choice 1. Number 41, a gas station is doing a study, so they want to know which one is most biased. Choice C, interviewing customers who call a 1-800 number to a customer that's on the bottom of a customer receipt. If you put a survey on the bottom of a receipt, that's biased because number 1, they already shopped there. Number 2, they're probably only going to do it if you provide them a reward to go back. The other choices are all unbiased. Every fifth customer, that's unbiased. Customers chosen at a checkout by random, that's about unbiased. And then interviewing every customer who comes into the station on a day of the week, chosen at random out of a hat, that's unbiased. Anytime you're controlling who's part of the study, that means that's biased. At number 42, we have another observational sample here. They're watching a crowd go to a concert, and they're trying to see how animated they are at the concert. They just watched something that's already happened. So 42 is B. In 2004, and New York City found that 212 out of 1334 participants had hypertension. So here's the results of the simulation, and they want to know which one of these answer choices shows 95%. Remember, 95% is the average plus or minus double the standard deviation. And double the standard deviation is the margin of error. Margin of error is the plus or minus number here. So 0.16 is the average, and the margin of error is 0.02. So if you go to 0.02 this way, we get 0.14. And if we go to 0.02 that way, we get 0.18. And between these two lines would be 95% of the data. If I go between these two lines, that's choice A. That's not 95% of the data. There's way too much outside that window. So let's get rid of those lines and only focus on this one, which is 0.16 plus or minus 0.02. 0.16 plus 0.2 and 0.16 minus 0.02. And that's choice B. Number 44, a group of students were trying to determine the portion of candies in a bag that are blue. The company claims that 24% of them are blue. They did a sample based on that premise, and here's the simulation, normally distributed, right? With an average of 0.254 and a standard deviation of 0.06, and they want to know where's the middle 95%. Mean plus or minus 2 standard deviations. So the mean plus or minus double that will lead you to choice B. Number 45, they did a poll, and Mayor Ortega's re-election campaign, they found out 264 out of 550 likely voters said they would vote for Mayor Ortega. Which one is the least appropriate statement to make? Well, the answer is choice A. We can't guarantee or tell you the odds of something happening based on one survey. 48% chance that Mayor Ortega wins? That's not true. Even though 48% said they would vote for Mayor Ortega, that's not going to determine the outcome. All these other things are true. And number 46, where would we get the least biased collection? Wanting to know how many times per week students exercise. They should talk to every fifth person that enters the gym? No. In the junior class? No. Entering the library? No. Entering the building? Yes. Entering the gym, it would only be people that are exercising. Junior class is only one specific group of people, maybe people that are more or less likely to exercise. Entering the library are people that are probably less likely to exercise because they're studying or reading instead. Well, entering the building is the answer. All right, 47. The cafeteria food manager wants to study the eating habits of a group of employees. They just sit back and watch people eat for a few days. And what kind of study is this? Well, watching people is observational. Which statement about statistical analysis is false? Experiments can suggest patterns. That's true. Experiments can determine cause and effect. That's true. Observational studies can determine cause and effect. That's false. We can't determine cause and effect when all we're doing is sitting back and watching what's already happening. And observational studies can suggest patterns. That's true. So the answer is C. Number 49, we have an experiment here because the teacher randomly divides all of the students into two groups, grading homework in one group and does not grade homework in the other group. And then comparing the results. That's a controlled experiment. That's A. And then number 50, which statement is most accurate? Survey about parenting styles given every 10th student entering the library. Well, parenting styles being done by a survey in the library will probably be this, right? Because it seems like better kids, better students go to the library. Observational student, determining the cause. Remember, we just said cause and effect can't be determined by observational studies. So it's not that one. Margin of error increases as sample size increase. Now, usually margin of error decreases. The more people we talk to, the less likely our survey is, or our data is, to be biased. It's going to have low variability when we talk to more people. And then D, a survey collected from a random sample of students in a school can be used to represent the opinions of the school. That should make sense. That's the right answer. A survey, 200 responses, 65% of the voters liked pizza. They did a simulation. Here's all the results of the simulation. What is the margin of error? The margin of error is just, remember, the window of 95% is mean plus or minus 2 standard deviations. But if we just are asked about the margin of error, we just care about the 2 standard deviations. So all we have to do in this question is take the mean standard deviation and double. And that's why the answer is, if they wanted the window, it mean plus or minus 0.07. Number 52 is a controlled experiment, because we want to know if there's a cause and effects solution here. These 3 things are all asking for people's opinions or asking just to watch something happen. We need to control the outcome. We need to see a cause and effect, so that's why it's D. Number 53, again, this is asking almost the exact same thing, cause and effect. If a single variable has an impact on the given population, that's a fancy way of saying cause and effect. So controlled experiment. We can skip question 54. We've already done that one. We can skip 55. We've already done that one. 56, we did 2 surveys. We sampled 5 teens in 100 different simulations. We sampled 5 teens in 100 samples. And we sampled 50 teens in 100 samples. And you can see that this one has a much larger standard deviation. The averages are almost the same, but this one has a much larger standard deviation. And that's because a larger sample size makes a smaller margin of error. Which choice shows that? Choice C shows that. Larger sample size makes a smaller margin of error, and it also will lead to a more accurate estimate. 57 you can skip because we've already done that question. 58, 55% of the candies at a company are blue, 30 are brown, 25 are yellow. Each bag holds 65 candies. The simulation was run 200 times, each with 65 in the bag, based on the premise that 45% of the candies are whole. Here's the results of the simulation. So I'm just going to show you my math here. About 45% of the candies were blue in the entire study. A mean of 29 blue candies means that 45% were blue. The window of 95% is between 33.6 and 57.1%. So any result between these two is a valid result, because 95% of the data, 95% of the simulation should fall between this window. And Bonnie's found that her bag had 24 candies. Well, 24 candies is 36.9% blue. That falls within this window. So D, this is just a normal bag of candy. 24 in that bag is perfectly normal. That's all for today. Thanks for watching.